So in today's class, let us get started with electrostatics. So the first topic in electrostatics is electric field. So let us see what is electric field. So electric field is a region surrounding an electric charge or a group of charges in which another charge experiences a force. That is called as electric field. So let's write the definition. The region surrounding an electric change or an electric charge or a group of charges in which another charge experiences a force is called electric field. That is, electric field is denoted by E bar, and E bar is F bar by Q, Newton per Coulomb or volt per meter. This is one definition, or it is also defined as the negative gradient of a potential due to a charge. That is, E bar is equal to minus del V, volt per meter. Now let us understand what is intensity of electric field. So it is the force which is experienced by a unit positive charge which is placed at that point. So let's see how to define it. So electric field intensity is defined as the force experienced by a unit positive charge placed at that point. Now let us see what do you mean by electric flux. So electric flux is the total number of lines of force in any particular electric field. So electric flux is defined as the total number of lines of force in any particular electric field, or in other words also we can define it. In other words, the number of Faraday tubes dissipated from a charged surface is also termed as electric flux, and the electric lines will be more when the passing electric flux will be more, and vice versa. and it is represented by the symbol Xi, and this displacement is equal to the charge itself. That is, flux is nothing but displacement, that is equal to charge. Charge is denoted by Q and flux is denoted by Xi. Hence, it is measured in Coulomb because unit of charge is Coulomb. So that's why flux unit is also Coulomb. Now next very important topic, it is Gauss law. So first let us write the statement of Gauss law. According to Gauss law, the net flux, now just now we have understood what is flux. So the net flux emerging from any closed surface is equal to the total charge enclosed within the surface. That is, Xi is equal to Q. So Xi is the displacement, that is the flux, and Q is the charge, where Xi is net flux emerging from the surface and Q is charge enclosed by the surface. This is the statement of Gauss law. Now let's see how to express Gauss law in differential form. So the Gauss law can be expressed in differential form as integral del dot d bar dv is equal to integral rho v dv, or you can write del dot d bar is equal to rho v. So what does this state? This states that divergence of electric field is proportional to the charge at that point. So now let us see what are the applications of Gauss law. Applications means where Gauss law is used. So you can find its applications in, you can find electric field due to long infinite wire using Gauss law, and then you can find electric field at any point on a uniformed charged sphere. So like a sphere which has charge throughout, you can find its electric field at any point using Gauss law. And number 3, you can find electric field at any point due to infinite charged surface using Gauss law. So these are the 3 applications. Now, after understanding the applications of Gauss law, we will see what are the limitations of Gauss law. Limitations means what are the disadvantages or where Gauss law is not applicable. So number one, it cannot be used for disc and ring type surfaces. So it is mostly used for wire type surfaces. Number two, it is applicable for symmetrical surfaces only. Symmetrical means which is in regular shape. And number three is it is not applicable to non-Gaussian surface. Means to the surface where Gauss law is not applicable. Those are called non-Gaussian surfaces. So it is not applicable to non-Gaussian surfaces. And if the charges lie outside the surface, then it cannot be used. Number five, for any closed surface, it does not show the exact shape. And number six, it is used only when the surface encloses the volume completely. Means if it is a closed figure, it is a closed surface. Only then. Now